Our universe is vast. It is a sea of countless stars spread across unimaginable distances. For most of human history, we could only look up and wonder. We saw these distant suns as mere points of light. We dreamed of other worlds orbiting them, but they were always just out of reach, mysteries locked away by the sheer scale of space. We told stories about them. We imagined what life might look like under a different sun. Yet for so long, these were just dreams, whispers in the long night of our cosmic isolation. The stars were beautiful, but they were silent companions in our journey through time. Then, things began to change. Our technology grew more powerful. Our eyes became sharper. We built telescopes that could peer deeper into the void than ever before. We started to find planets. First, giant worlds of gas, unlike anything in our own solar system. Then, smaller, rockier planets. We were no longer just guessing. We were discovering. One of these discoveries brought the dream closer to home than ever before. It was a planet orbiting the very nearest star to our own sun, Proxima Centauri. We call this world Proxima B. It is our closest cosmic neighbour, a world just 4 light-years away. Proxima B captured our imagination for a simple reason. It orbits within its star's habitable zone. This is the Goldilocks region. Not too hot, not too cold. It is the delicate band around a star where liquid water could potentially exist on a planet's surface. And where there is water, there could be life. At least that is the hope. Imagine looking at a familiar dark landscape night after night. You know its contours, its shadows. Then one evening, you see something new. A faint, structured pattern of lights appears where there was only darkness before. This is what happened to a team of astronomers. They were observing Proxima B as they had done many times before. They were gathering data, patiently sifting through the faint signals coming from our stellar neighbour. They were not expecting any surprises. Science is often a slow, methodical process. It is about careful observation and patient analysis, not sudden dramatic revelations. But then they saw it. A strange and unexpected signal. It was a pattern of light concentrated on one side of the planet. Specifically, on the night side, the part of the planet turned away from its star. This was not a random flash, it was not a uniform glow. The light appeared to be clustered, forming a pattern that looked eerily familiar. It resembled the way our own cities light up the darkness of Earth's night, a web of interconnected points of luminescence shining out into the void. The discovery was startling. It was something no one had predicted. It sent a quiet shockwave through the scientific team. How is it possible to see something as faint as city lights from over 4 light-years away? The distance is immense. It is about 25 trillion miles. Seeing a planet there is hard enough. Seeing lights on its surface sounds like science fiction. The answer lies in a remarkable piece of technology called the James Webb Space Telescope, or JWST. This is not just any telescope. It is the most powerful space observatory ever built by humanity. It is our great eye on the sky, designed to see the universe in infrared light, which is invisible to our own eyes. The JWST has a massive mirror, over 21 feet across. This giant mirror allows it to collect vast amounts of light, even from the faintest, most distant objects. It is also incredibly sensitive. It can detect the subtle heat signatures and faint glows that tell us about the composition and conditions of faraway worlds. To find these lights, astronomers used a technique called direct imaging. They pointed the JWST directly at the Proxima Centauri system. They then used a special instrument called a coronagraph. This device acts like a tiny artificial eclipse, blocking out the blinding glare of the parent star, Proxima Centauri. With the star's light suppressed, the much fainter light of the planet Proxima B could be seen. But the team went a step further. They did not just look for the planet's reflected daylight. They waited for the planet to orbit to a point where its night side was facing us. This is the part of the planet that should be completely dark. Any light detected from this dark hemisphere would be strange. It would have to be coming from the planet itself. It could not be mere starlight bouncing off clouds or oceans. It would have to be emitted light, a source of energy shining from the ground up. And that is precisely what they found. Nature's grand illusions. Before we jump to conclusions, we must be good scientists. We must be skeptics. The universe is full of wonders and nature is often more creative than we can imagine. So, what could create these lights if not a civilization? There are several natural possibilities that we have to consider very carefully. One idea is widespread, intense volcanism. Imagine a region on Proxima B's surface covered in massive volcanoes, a supercontinent of fire with rivers of molten lava glowing brightly in the dark. This would certainly produce light and heat on the night side. However, the pattern of the light seems to argue against this. Volcanic hotspots are usually random. They follow fault lines, but they do not typically form the kind of interconnected, grid-like pattern that the astronomers observed. Another fascinating idea involves a phenomenon we do not have in our own solar system. Proxima B is tidally locked to its star. This means the same side always faces the star, creating a permanent day side and a permanent night side. This could create extreme weather. Perhaps powerful planet-wide lightning storms are concentrated on the night side. Imagine a perpetual thunderstorm of incredible scale, with lightning flashing constantly in a specific region. This could create a localized glow. It is a creative and interesting idea, one that highlights the truly alien conditions that might exist on such a world. But again, we face the problem of the pattern. Lightning is chaotic. It is random. There is also the possibility of some exotic form of bioluminescence. Perhaps vast colonies of glowing organisms, like the fireflies or glowing algae on Earth, but on a planetary scale. This is a tantalizing thought. Life creating its own light. Yet, for it to be visible from so far away, its intensity would have to be immense. Far greater than anything we know, and it would still need to explain the city-like structure. Nature is clever, but each natural explanation seems to fall just a little bit short. So, we have looked at nature. We've considered volcanoes, lightning, and even glowing life forms. Each of these ideas honestly has its own beauty, but none of them seem to perfectly explain the data, the structure, the stability, the specific signature of the light. This forces us to consider the other possibility, the one that sends a shiver down the spine, the one that honestly changes everything. We must consider the possibility that these lights are artificial, that we are seeing the product of technology, that maybe we are looking at the cities of an alien civilization. It's a breathtaking thought. It is a hypothesis of last resort because the evidence required must be extraordinary. But, it fits the observations in a way that the natural explanations just do not. A technologically advanced civilization would need energy. They would build power plants, they would construct cities, and those cities would leak light and heat into the surrounding environment. From a great distance, this leakage would appear as a faint, structured glow on the night side of their planet. It would look exactly like the signal we have received from Proxima B. The pattern of the lights, with its clusters and connections, is reminiscent of our own urban sprawl and infrastructure. It suggests a society that has organized its habitat, building in specific locations for specific reasons. Maybe these are population centers. Maybe they are industrial complexes or energy-gathering facilities. We can't really know for sure. But the very structure of the light whispers of intelligence. It hints at purpose, at design. It's a faint 4-light-year-old echo of a thought, of a plan, of a civilization at work, illuminating its own small corner of the dark. This doesn't mean they're like us. Their biology could be entirely different. Their society could be organized in ways we can't even comprehend. But the laws of physics are universal. The need for energy is likely universal for any complex technological society. If a civilization exists on Proxima B, it's plausible they would harness energy. And that process, no matter how efficient, would likely produce waste heat and light. It's this technological fingerprint, this unavoidable byproduct of civilization, that we may have just detected across the vast, silent ocean of interstellar space. A question echoes. For all of human history, we have asked a simple, profound question. Are we alone? This question has been the domain of philosophers, priests, and poets. It has fueled our myths and our religions. It has driven us to look to the heavens and wonder if anyone is looking back. We've felt a deep, cosmic loneliness, a sense that we are a unique and maybe solitary spark of consciousness in a silent, unthinking universe. This feeling has shaped our understanding of ourselves and our place in the grand scheme of things. It has made our world feel both precious and isolated. The discovery on Proxima B, if it is confirmed to be artificial, would answer that question with a resounding no. We would no longer be alone. We would be part of a larger cosmic community. Even if we can never communicate, even if we can never visit, the knowledge itself would be transformative. It would fundamentally change our perspective. Humanity would have to reckon with the fact that we are not the only thinkers, not the only builders. We are just one of many, a younger species perhaps, looking up at the lights of our older, more established neighbours. This realization would be humbling. It might make our own conflicts and divisions seem small and insignificant in comparison. The challenges we face as a species, climate change, disease, war, might be seen in a new light. Knowing that another intelligence exists could inspire us to work together to ensure our own long-term survival. It could foster a new sense of global unity, a planetary consciousness. We would be Earthlings, representatives of our world in a cosmos that we now know is inhabited by others. The psychological impact would be immense and could echo through generations. Of course, it could also bring fear. The unknown is often frightening. We do not know the nature of this potential civilization. We do not know their intentions. History is filled with stories of encounters between different cultures, and they have not always been peaceful. But this is not an invasion. It is not a direct contact. It is the faintest of signals, a gentle whisper from across the stars. For now, it's simply knowledge. The knowledge that the universe is more interesting, more complex, and more alive than we ever dared to believe. The silence has been broken, and the question, are we alone, has found a possible answer. What do we do now? Where do we go from here? The first step is more observation. Science, after all, demands patience and rigor. We must continue to watch Proxima B. We must use the James Webb Space Telescope and every other instrument at our disposal to gather more data. We need to study the spectrum of this light in greater detail. Can we determine its chemical composition? Does it change over time? Are there patterns in its flickering that might suggest activity? Every new piece of information is a new clue in this incredible detective story. We must also look for other signs. If there are cities, there might be an atmosphere with industrial pollutants. The JWST is capable of analyzing the atmosphere of exoplanets. It can look for the chemical signatures of gases like oxygen, methane, and even complex molecules that could only be produced by technology. This search for techno-signatures is a new and exciting field of astronomy. The lights of Proxima B have given us the perfect place to start looking. It's a focused, targeted search for the broader signs of a civilization's impact on its environment. This discovery also encourages us to look at other nearby stars with renewed purpose. If life and intelligence can arise on our nearest neighbor, then the odds are good that it has arisen elsewhere too. Ultimately, this discovery invites us to dream, to imagine what this other world might be like, to wonder about the beings who might live under the light of a dim red sun. What stories do they tell? What art do they create? What do they wonder about when they look up into their night sky? Perhaps they are looking back at our sun, a bright yellow star in their sky, and asking the same question we have asked for so long. Is anyone out there? The universe has presented us with a beautiful, profound mystery, and the journey to understand it will engage our curiosity for many years to come. The cosmos does not give up its secrets easily. Each discovery is hard-won. It's the result of decades of work, of brilliant minds, and of an unyielding human desire to know. The lights of Proxima B are the latest chapter in this long story. They're a puzzle wrapped in a mystery trillions of miles away. It's a puzzle that we are only just beginning to unravel. We stand at a unique moment in history. We may be the first generation to have a credible scientific reason to believe that we are not alone in the universe, a reason written in faint light from a neighbouring star. We must proceed with a sense of wonder, but also with caution and humility. We do not have all the answers. The data is still new, and there's much more work to be done. It's possible that a natural explanation will eventually be found, one that is even more strange and wonderful than we can currently imagine. Science is a journey of discovery, and sometimes the path leads to unexpected places. The most important thing is that we keep looking, that we keep asking questions, that we never lose our sense of awe at the scale and complexity of the universe we inhabit. Whether Proxima B is home to a civilization or a strange natural wonder, the search for an answer will teach us more about the cosmos and our place within it. It will drive us to build better telescopes. It will inspire a new generation of scientists, engineers and dreamers. It will push the boundaries of our knowledge and our imagination. The quest is what matters. The act of reaching out into the great darkness with our instruments and our minds is a noble and worthy endeavor. It is an expression of the best part of our humanity. So the next time you look up at the night sky, think of Proxima B. Think of that faint red star, our closest neighbor. Think of the world that circles it and the mysterious lights that may be shining on its surface. The universe is vast and full of mysteries, and we are just beginning to listen to its story. The journey is far from over. In fact, it may have only just begun. We must keep exploring, we must keep wondering, and we must continue our collective journey together through the wormhole. Please like and subscribe to Cosmic Discover.